Alright guys, I just hooked this thing up to half-wave rectified mains. It is freaking sweet, check this out. I've got a 10 amp fuse fast blow in series with it. I tuned the coil a little bit differently. I've got it set to around 276 kilohertz on the function generator. Now before, in my last video, I had this set up so that it was using what's called a phase lock loop, so that it could lock onto its own resonant frequency and stuff, and that didn't really work very well. It just wasn't reliable. So fixed frequency, just drive it at whatever, and it seems to work a lot better. I think part of the reason is that especially as I got too close to the secondary, with drawing an arc and all that, essentially the primary would act like a short circuit, more or less, and it would cause the frequency. It would cause the just due to the coupling factor, the leakage inductance of this primary coil to resonate with the capacitor, and it would lock onto that frequency. And well, now it's not really transferring power into the primary, and you just get a huge amount of reactive power, and it just blows up. So, anyway, done talking. Check this thing out. That's so fun. It makes me giggle. And how hot are things getting? Primary gets pretty toasty. Secondary is pretty cool. I want to see this thing with shit, what do you call it? Like properly filtered steady state DC. None of this halfway rectified garbage. What about my smoothing capacitors? These smoothing capacitors are under a lot of stress because they're basically charging up to the 170 volts DC, and then this thing just draws so much power they immediately go back down to zero. And then we pump more energy into them with the halfway rectified mains. So yeah, I'm being pretty abusive to this thing overall. Let's just hook up more capacitors and see what happens. So I've got some are they? Actually, before we do that, let me increase the frequency back up to about 280 kilohertz. So this is 5 kilohertz higher. So I think at the higher frequency, it's making longer arcs, but there's less current in the output. This makes sense because, of course, as I approach it and as I draw a shorter arc, just me having this giant 27 millimeter wrench near it, I'm essentially detuning it, and it's going to have less power transfer. Anyway, if I take the frequency down from 280 back down to around 270, let's see what this does. Very poppy. I don't know what's going on there. So 273. Let's go up to 275. And something here is getting really hot. Probably these filter capacitors. They are not rated for this sort of abuse. Oh, holy shit, I just blew up a capacitor. Huh. Oops. Yeah, check it out, guys. Come on, focus. Focus. Do I need to use Abe's magic words? Focus, you fuck. It's not gonna work. Anyway, yeah, that capacitor right there just blew up. Let's zoom in. Let's do that. There we go. That's better. Yeah, putting it under a little bit too much stress, I think. What about the one on the other side? I don't remember if I have capacitors on this side or not. Anyway, this is a good... so you can see I'm using the HY1920P transistors. Couldn't even be bothered to cut off the legs. Alright, let's do it again. Let's increase the frequency up to around 278 kilohertz. Let's go off with the lights. Ah, nice and dark. Yeah, I think we have to wear some ear pro for this. Shit. All right, see you guys.